Easy, Maj. Easy, Maj. Take it easy, buddy. This guy over here. Did you? For what? More What'd you get? Nice. That's awesome. All right, morning, everybody. For at least the next week or two, we will be live streaming for our COVID folks at home. So you'll see that I'll be doing this. And I'll just kind of take this around with me. That's why those books are stacked up so I can point them at the boards when the time comes. We have a fire drill in about 4.5 minutes, but let's check that homework just to make sure you feel pretty good about where you're at. No, I just have to find it. Let's see how deep I have to go. That's apartment. Oh no, go back. Hopefully it was relatively easy. My bad on messing it up. Hopefully you saw that and you fixed it. I went back to do the answers. I'm like, that's not factorable. And if you did like quadratic formula, that's fine. Chapter 2, homework. Homework 2.1. All right, so I ended up going back and changing number 3, or number 2, sorry. So there's number 1. Just take a look, see how you did. Let me know if you have questions. Let me blow that up a little bit. Let me make sure I am Bluetooth connected. In my ear. All right, so if you're at home, just give me a shout if you need something. Now, I think there's a few ways to do some of these problems. Like finding the vertex, you don't have to do negative b over 2a. You could complete the square. Sure. That's way more work, though. And we'll talk about that today. We'll make sure that we're cool with that idea. Something I know you've seen before. But just to make sure you're good. And finding the x-intercepts, you could use the quadratic formula if you really wanted to. Like, you've got options. But I think negative b over 2a is the fastest way to find the vertex. And if a function's factorable, that's going to be your easiest, most direct route. Least amount of simplifying to get you where you want to go. Okay, scrolling. Number 2. So I screwed up and I put +4 at the end of this one. So if you didn't see that I made that change and you still have it as +4, that's fine. It just wasn't factorable. 2 numbers that multiply to +4 and that's a -3 don't exist. So you would have had to use quadratic formula or something, complete the square, set it equal to 0 and go that way. But I wanted it to be factorable. I wanted it to be relatively nice. So I changed it. So if you caught that, if you saw my message, good. If you didn't, that's all good too. You don't have to go back and change it, but just so you see how that goes. And you see with number 1, when I found the vertex, I did all this work and I showed negative b over 2a, and then you plug it back in, I showed all that substitution. But once I show that once, I think you know that I know how to do it, and now I can just jump right to it and say, hey, negative b over 2a is 3/2. And then I'm just going to plug it in. I don't have, like, it's just the arithmetic. So make that quick. Make that happen relatively quickly. And fractions or decimals, totally up to you when it comes to how you write it. As long as that decimal's got an end, you can use it. Okay, big thing I'm looking for, axis symmetry's got to be x equals. If you don't have x equals, we're in trouble. And if you want to just circle like these answers separately, that's cool. You don't have to write it as the solution set. But if you do, that's nice too. Just list them from least to greatest, from left to right, or from negative side to positive side. Questions 1 or 2? All good? Sweet. All right, number 3. And then we'll go take a walk. Okay. We didn't really talk too much about these in class on Monday, so I wanted to put one on there just to be Be safe. Obviously, y-intercept is good, but the vertex is negative b over 2a. If there is no linear term, no degree 1 term, then b is just 0, right? 0x to the first. So that's where that 0 comes in. Axisymmetry, x equals 0. Or you can just say the y-axis. That's cool too. Orientation opens downward, right? Because that leading coefficient is negative. But then when I go through the process, I didn't put e on the side there, but that's that finding the x-intercept. Setting it equal to 0 and solving. If there's only one x in the problem, go get it. Just go solve for it. You don't have to factor if you don't have different degree terms in there, right? X squared and x, that forces us to factor. But if it was just x, or just x squared, or just x to the 7th, or whatever it was, there's only the one, you can go get it, right? Just solve for it. Subtract 32 and divide by negative 2. Take the square root. When we take the square root, we get that plus or minus version of it. Did you guys simplify radicals last year? Like that?
Good morning, Mustang. Just want
Fire drill.
to know we're going to be doing a fire drill. Again, this is only a drill.
We gotta try to stay as socially distanced as we can while we do this. But let's see if we can get ourselves a head start so that we don't have to quite straight out towards the locker, take a right and go down out by the tennis court. I will meet you out there.
May I have your attention, please? May I have your attention?
Come find me when you get there.
There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. May I have your attention, please? May I have your attention, please? There has been a fire emergency reported in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators.
All right, Mustangs, good job. You may now return to class.
That's easy. Put it right near the door, right? They are, yeah, I saw some. Somebody bought one yesterday, so. Go quick.
Okay, thank you.
Yeah.
So you guys have done all that simplifying radical stuff, right? I don't have to go over that. Okay. I thought so. Because I want to move on. I want to do some other stuff. You might be front and center there, McCarthy. It's up to you. You can slide up to the red one if you want. Push this out a little bit. Cool. All right, let's keep going. We're all good? 2.1. A, all good. All right, we got to finish up 2.1. So we're still there, still talking quadratics. But I want to get us, hopefully, just a little bit further. I'd love to finish it today. Okay, 8:35 to 9:25. What's that? Yeah, so he might just not have logged on yet. But I recorded anyway, so that you don't have to get up. If you're home, it's all good. All right, what do I want to do here? Oh, I know, it's brutal and stuff. All right, we ended off with one on Monday. What was that one? Do you have that? Can you open back your notes and give me that? I don't know if anybody wrote it down. The one where we were trying to factor where A wasn't equal to 1 in ax squared plus bx plus c is like 2x minus 15x minus 8. I think that was it. Is that the one? And we tried to get ourselves to here. All right. And I just wanted to make sure that we talked about it again. You feel pretty good about what's happening, but I want to show you the algebra behind it because then we can use it. All right. So our setup is still the same. I want to know two numbers that add up to b and multiply to a times c. All right. And so in our case over here, we're trying to get two numbers that add up to negative 15 and multiply to whatever 2 times negative 8 is, which is negative 16. I gotta turn that light off. It's too bright. So what two numbers does both? 50-50 shot? Oh, wrong. Okay. Negative 16, positive 1. Good. And what a lot of people would do from there is they would just jump right into the box, right? Put the ax squared first, put the c last, and then they would use these two numbers to split up x. They put something x and something x, okay? And that's great, right? You can do that, right? 2x squared minus 16x plus 1x minus 8 equals 0. And what's happening with the box that I'm going to do over here, I want to show you the algebra behind it because I want to be able to use that instead. So 2x squared minus 16x, positive x, and negative 8. All right? We're going to find the greatest common factor of each row and each column. And whatever's on the outside, those will be our factors. Okay, so 2x squared and negative 16x. Greatest common factor. What number goes into both 2 and negative 16? If you've got x squared and x, how many can I take out without taking too many? Just x, right? Can't take more than I've got. Okay, what about x and negative 8? What do they have in common? Just 1, right? And I know you got these negatives here, so we got to keep an eye on that. When you've got negatives stacked on top of each other or next to each other, that's a great time to take them out. All right, so let's go vertical. 2x squared and x, and negative 16x and negative 8. You've got the negative, there's the time you want to take that out, okay? But what's really happening that gets us down to here, 2x plus 1 and x minus 8 equals 0, is something in the background that I don't know if you've seen, maybe you have, maybe you haven't. It's called factoring by grouping. And it's going to come into play a lot as these degree functions get a little higher. So what we do instead, or also, I don't know why you do both. You don't have to do the box and this, but I want you to be comfortable with factoring by grouping. You take the first two terms. It has to be an even number of terms. It can be 4, it can be 6, it can be 8, it can be 10. And you find the greatest common factor. So what is the GCF of 2x squared minus 16x? Oh, well, it's 2x right there. What do you have left behind? Well, I took 2x from 2x squared, so that's x. And I took 2x from negative 16x, so that's minus 8. And then I do it again. What is the greatest common factor between x and negative 8? Well, 1. So take out a 1. What do I have left? Exactly what I had before. Now, quick side note. Two things being multiplied here and two things being multiplied here. What do they have in common? So I can pull out D just once, right? I don't pull it out twice. I just pull it out once. What do I have left behind? A plus B. Okay? Two things being multiplied here and two things being multiplied here. What do they have in common? Two things being multiplied here, two things being multiplied here. What do they have in common? You said D. So we took out D once and we wrote down what was left. 2x times x minus 8. Two things being multiplied there, 2x and x minus 8. 1 times x minus 8. Two things being multiplied there. What do they have in common? X minus 8, the whole thing, right? And it's just that D is just, in this case, x minus 8. This is a binomial common factor rather than a monomial common factor. And so what can we do? We can take it out. X minus 8. What do we have left? Well, A plus B. Well, A in this case was just 2x. And B in this case was plus 1. What's 3 times 2? What's 2 times 3? Does it matter what order I write multiplication? So is this the same as that? There you go. Okay. And so that's the factoring by grouping, is these like couple steps right here that get us to the exact same spot that using the box would. Okay. And then you just solve it. All right. 2x plus 1 equals 0. Subtract 1, divide by 2. 8x or x minus 8. So you get your 8. Okay. Have you seen that process before? Factoring by grouping. Awesome. Let's do another one. 3x squared plus 4x minus 4 equals 0. Now, I'm assuming you remember all the other stuff. Y-intercept, -4. Vertex, negative b over 2a, and plug it back in. All right, axis symmetry, x equals whatever that x value was. That's all still there, but I want to focus on the other things. Okay, let's factor this. So how do we start? What's the first place to begin? Right, figure out what's going to go here and there, right? Is that what you're thinking? So two numbers that add up to b, so two numbers that add to 4, and multiply to whatever a times c is, so it's -12. What two numbers do both? I'm going to bring this with me. Get over here. What two numbers do both? Add to 4, multiply to -12. Actually, perfect. Does it matter what order we choose? It doesn't. So if you said -2 and 6, all good. And so the idea that we want to do, I want to see this step. I want to see you break that 4x apart using those two numbers, because that's really the only purpose of using that diamond when a is bigger than 1. Like, I can't just say x plus 6 and x minus 2. Those aren't going to be the answers. Okay. Now let's try factoring by grouping, just so we can get the hang of that. Because I feel like the box is something you've done. Let's try to factor by grouping. Okay. So we look at the first two, and we take out its greatest common factor. Just factor out whatever is in common between 3x squared and 6x. 3x, good. And then we write down what's left behind. Well, it took 3x from 3x squared, so I've got an x left. And we factored out 3x from 6x. And factoring is just undistributing, right? We're just dividing. So think of it like that. Okay, cool. -2x, minus 2x minus 4, what should we take out? What do they have in common? -2. Now watch this. If I just took out a +2, -x minus 2, are these two parentheses the same? No, and so it's not this, and that's not good. I want to make sure that when I factor, that I pull out whatever I need to create the same parentheses here and here, because I want to factor again. Really, we're factoring like just kind of plain old GCF right here, but then we have, all right, 2 terms and 2 terms. What do they have in common? X plus 2, take it out. If you take x plus 2 from here and from here, right, we only have it once, right? We pulled out d once from both. What do we have left behind? 3x minus 2. And now you can solve. Okay, x plus 2 equals 0, so x equals negative 2. 3x minus 2 equals 0. Add 2, divide by 3, that's 2/3. If you want to write the solution set, smallest number, and when I say smallest, I mean furthest left on the number line, not closest to 0. Small and big. And you can use the box. I know it's there, but I want you to get the hang of this. I want you to kind of see what this feels like, because we'll kind of go up from there. And I'll give you some practice with that. Let me just give you one to try. I want to have you actually sit here and try one. 4x squared, let's just keep going up. There we go. Plus 5x minus 6. And let's do it all. You know what? Let's call this f of x. Okay? Find it all. Find the y-intercept. Find the vertex. Describe the orientation. The axis of symmetry. And then lastly, find any x-intercepts. Take a couple minutes. See if you got it. So if you can do it, then we're good, and I can just touch on one last quadratic thing, and then we can move on. All right, so 4x squared plus 5x minus 624. 3. Yeah, it should work. Let me take attendance. Oh man. All right. So we should have 9, 4, 6, 9. Cool. I'm gonna start putting answers up over here so you can check when you're ready. I am definitely breaking out the calculator to do that. But nah, I'm gonna have fun. Let's do it. Why not? Make it a challenge. Times 16, 60 and 36 is 96. Negative 25 minus negative 125 plus 1. Wonder how I did. Continue. Oh, I should show you something. Oh, you're gonna like this. If you have your calculator, take it out. I gotta show this to you. It is too nice There's so much stuff this calculator can do, you have no idea yet. I'm going to try to show you as much as I can throughout the year. And it's just going to be times like this where someone just pops into my head, and I'm like, you know what, this might be easier. But while it gets loaded up, I'll finish. Opens upwards. Axis of symmetry. And then and the box still works. Feel free to use it. Box is still there. But factoring by grouping is going to come in. You can't use the box if there are 6 terms. I mean, you can, but you have to draw the right shape box. You got to do a 3 by 2. And that can be just confusing. We're just not used to that. I'll let you finish, and then I'm going to show you my little calculator thing, and then we're going to wrap up 2.1. Hopefully. Yeah. These days, man, these days, they go too fast. The other thing that I can mention while you're finishing up, that we have to make sure you get done this week. I'm going to post it every single day until the week's out. It's going to be the very first thing in the announcement. This is the week to sign up for See You Succeed. This is it. You got today, tomorrow, and Friday. Okay? I put the link right there. Super easy. You click on it, it takes you right to the See You Succeed website. If the folks at home have questions, there's a super quick, like less than 4-minute informational video that they can watch, that you can watch with them, so that they can get a good sense for what it is, so you don't have to try to explain it. They can. But right here, register here. Boom. Click on it. You fill out this form, and you're in. Okay? There's just a couple keys that I got to make sure we take care of. Right? Fill out all that stuff. You know, name, date, birthday, phone number, email address, whatever. Have you participated in See You Succeed before? Maybe you have in an English class or Spanish or something. Maybe not. Address, parent info, your criminal record for all those felonies, I know. What high school you're attending. Okay, so you got to scroll down to Ponderosa. Mathematics. There are 2 college algebra classes. Choose mine. That gets you onto my roster, so I know that you're good. Okay, and if you're also taking English, you can do that too. You can sign up for both at the same time. If you're taking Weller's Intro to Fiction, you can do that as well. Okay, some ethnicity information if you'd like. That's your choice. You have to click there and submit, and you're done. Okay. The day before, the announcement before, there was a lot more information about it. So if you saw Tuesdays, oh no, maybe Mondays. Because I wanted to mention, oh, here it is. See You Succeed, please read. All the info right there in case you need some extra details. $77 per credit, 4 credits for the fall, 3 credits for the spring. You can do one or the other or both. But you don't sign up for college trig until January. All right, cool. Super quick calculator skill to help me with that -5/8. Okay. If I wanted to evaluate f of -5/8, I could just go to here and type it out, right? And I could do that. 4 times negative 5/8 to the, and just, I would do the whole thing, right? But what if I wanted to evaluate like a bunch of different spots on the same function, or maybe I just didn't want to type negative 5/8 over and over and over again? What you can do instead, so you can go to y equals and you can type in the function, just the whole thing, 4x squared plus 5x minus 6. Okay. Where would you go once your function is typed in to look at a table of values to find your points that go on there? Yeah, right, graph. So above graph is table, so second graph or table. But the way that most tables are going to start is they're going to start around 0 and go up by 1. Where's negative 5/8? Somewhere in there. So what I wanted to do is I wanted to show you some different ways on how to do that. If you wanted to, second window, table set, to set up your table, you can have your table start at whatever number you want. And if I wanted to, I could have my table start at negative 5/8. I could just type in negative 5/8. I don't care what it goes up by. There we go. The first number is negative 5/8. Because that decimal ends, I feel really good that that's exactly right. Negative 7.7565. Okay, negative 7.5625. There we go. But it doesn't give us the fraction version, which can be a little frustrating. But you could come back to here if you wanted and go negative 7.5625. Math. Option number 1, change it to a fraction, and it'll give you that fraction. I know, right? But there's another choice. Because maybe setting up your table to start at one number, but then going up by ones, maybe you have a bunch of different values that you want to plug in. Okay? Here's what you can do. Maybe you've never done this before. Look at these last two options down here at the bottom. Independent is set to auto, and dependent is set to auto. That means, hey, calculator, automatically spit out all these numbers for me. You know what? I don't want all of the numbers. I want some specific ones. I want to ask for some of my own independent numbers. Because maybe I want negative 5/8, and I want 2/3, and I want pi. And I can't create a table that's going to start at one place and go up by nice numbers and hit all those. So now if I set independent to ask, so press enter once you get there. And then I go back to my table, now it's empty. And now it's waiting for you to type in whatever numbers you want. Negative 5/8, my answer. Now look at that, negative 7.563. But if I hover over it, it'll give me the full answer. Okay, because there's only so much space in here. 1, 2, 3. It's like 1, 2, 3, 4, 5. I can only fit 5, not including the decimal. But they count the negative as a big enough space. Okay, and if I wanted pi, then I could do that, right? Second caret, and it'll give me the decimal approximation, right? Because there it is, 3.1416. No, it's 14159265358979323846626. Blah 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 blah. I think it was like 7th grade. My teacher had the digits of pi like up around her classroom. 7th grade math. I was bored out of my mind, so I memorized all of them. Now at this point, I only know like 15 or 20 digits because I just stopped. But obviously that decimal is going to go on forever. But you can type in anything you want, and it'll spit out whatever number you want. Okay. So table set to ask, it's amazing. You're gonna like it because once we get into some other stuff, chapter 2. That's what you're going to want. Nice, I got it right. Negative 21/16. Okay. All good? Got it? Sweet. All right. Last thing. My goodness, this class goes too fast. Let's go. All right. So we saw standard form. And again, I don't know why the book suddenly calls something else standard form, because a function in standard form has no parentheses, written largest exponent first and on down. That's called standard form. But there's two of them, right? So we've got, call it f of x, x squared, a x squared plus bx plus c. Yeah, home. I'm coming. Yeah, thank you. I just had the same thought. It'll be. There are the answers. Pause if you need to. Cool. All right. That's called standard form. There's another way to write quadratics, so we can see the vertex without having to solve for it. What's it called if I can see the vertex without having to do any work? You know what that form is called? Vertex form, also known as graphing form. And it's what happens when we complete the square. A, parentheses, x minus h squared plus k, where the vertex is located at h, comma, k. All right, because you've got your horizontal transformation on the inside happening to x. And all that stuff is going to come back. I told you I was skipping in chapter 1 because I hope you remember it. We're going to need it here in chapter 2. All right, so horizontal transformations are backwards. So that's why it's x minus h, but we're going to go to h. We're not going to go to negative h. We're going to go the other way. And then vertical shift up or down, whatever k is. But this constant is the same. This a and this a are the same. And so if I started with a function x squared plus 6x minus 1, I don't know, I'm making it up. Now I wanted to rewrite it in vertex form, in graphing form. How would you do that? If you wanted to go from here to there, because I think that there's two ways to do it. I don't care which way you do it. Option number 1 versus option number 2. If you wanted, you could complete the square. And I'm going to hope that you remember exactly what I'm doing right here. Okay? I'm going to add and subtract the same number right in here, because really I'm just going to add 0, because then the function won't change. And the number that I'm going to add is half of b squared. That's the magic. That's the money. That's what makes things perfect. Take this number, cut it in half, and square it. Half of 6 is 3. 3 squared is 9. Because when I factor the first 3, that quadratic trinomial right there, what two numbers add to 6 and multiply to 9? And 3 and 3, right? Both of them. So you've got like x plus 3 times x plus 3. Better known as x plus 3 squared, completing the square. And then I just put these together. Minus 10. And I'm done. I know where my vertex is just by looking. This is a horizontal shift left 3, right? So my vertex is at negative 3, comma, this is a vertical shift down 10, negative 10. All right, opposite of the inside, same as the outside. And here's my leading coefficient of 1. There's my leading coefficient of 1 that we don't have to write. But there's another way. You can find the vertex first. You can say, you know what, I'm going to do negative b over 2a, put it in, and see what I get. I'm going to take b, take the negative version, so negative 6, divided by 2a, so that's negative 3. And then plug it back in right here, right? Whatever g of negative 3 is, should be my vertex. So negative 3, comma, all right, negative 3 squared is 9, plus, okay, negative 18, so 9 minus 18 is negative 9 minus 1, negative 10. And now I just have to know g of x, right? I just have to know vertex form. A, x minus h squared plus k. What's a? This number. Whatever that leading coefficient was from the beginning. A, x squared plus bx plus c, it's the same. So it's just a 1, so I'm good. X minus negative 3. Okay, x plus 3 squared plus a negative 10, so minus 10. Same thing, right? So it doesn't matter. You can do it either way. I'm not going to ask you, hey, write this in vertex form by completing the square or by finding the vertex first. I don't care how you do it. I just want you to be able to do it. And I think the way that this saves us a lot of trouble doing it the second way rather than the first is when a just isn't 0, isn't 1. G of h of x. Give me a number there. Anything. 3x squared. Connor, give me another one. Plus 2x. Ethan. There we go. There's our function. And what could be a lot of trouble here is trying to complete the square. Because in order to complete the square, you have to factor out that leading coefficient. If you want to complete the square, and hopefully I'm just reminding you of stuff you already know. If I wanted to complete the square, I would have to take out the 3 from these first two terms. 3, x squared plus 2/3 x. Factoring is dividing. I divided this by 3, kept it out front. Divided that by 3, kept it out front. Well, 2 divided by 3 is 2/3. And now, inside here, I need to add and subtract the same number, so I'm adding 0. But that number is half of this squared. Okay, half of 2/3, cut it in half, and then square it. Half of 2/3 is 1/3. Square that, square the top, square the bottom, that's 1/9. I need to add 1/9 and take away 1/9. But the problem that I have is I want to just complete the square with these, not with this. And so realistically, what I want to do is I want to keep, sorry, that's an x, 2/3 x plus 1/9 inside, but take this 3 times 1/9 and bring it outside. It is just a mess. It gets really messy. There's a lot of ways to make a mistake. And now you have to factor what two numbers add to 2/3 and multiply to 1/9. 1/3, close. Yeah, 1/3. It's always half of this. 6, 3. Always half. This number inside here will always be half of b. And then I have to subtract this. Negative 1/3 minus 15/3 is negative 16/3. And that is a messy process. That there's a lot of ways to make mistakes. But what I find so much easier by trying, instead of option number 1, trying option number 2, find the vertex first. Just do negative b over 2a and then plug it back in. And let's see what we get. Okay, so negative b, so negative 2 over 2 times 3, so over 6. So negative 1/3, comma, calculate. I jump in, I type in, I'll just go this way. You can do the table thing, or you can just say, you know what, I've got 3 times negative, yeah, negative 1/3 squared plus 2 times 1/3, so plus, or minus 2/3 minus 5. Gives me, oh, what didn't you like? Oh, yeah, mama. All right, I want to show you something else cool. I made a mistake typing something in. And then we'll end, but give me like 15 seconds if that bell goes off. Sometimes when you type stuff out in here, you make a mistake. Whoa, right? I forgot to divide this by something. I was just typing too quickly and I got to there and it said, nope, you screwed up. Instead of retyping it and making the change, press the up arrow twice. Highlight it, press enter, it'll copy it down there for you. Now you're saying, but I have to So I put a 3 right there. And if I type the 3, don't leave. If I type the 3, it's going to erase the parentheses and it's going to do all this mess. Above delete is insert. Second, delete. Now I can put the 3, it's going to slide everything to the right. Change it back to a fraction. Negative 16 thirds. Hold on, watch this, watch this, watch this, watch this, watch this. Negative 16 thirds. All right, I know that it's ax minus h squared plus k. What was a from the beginning? What's that leading coefficient? So it's going to be the same right there. H is negative 1/3, so x plus 1/3 squared, k negative 16 thirds. Same answer, so much faster. There you go. Thank you, everybody. Check Canvas for a little practice. Hopefully that did it for 2.1. That was my hope. Thanks, everybody. Friday, expect to log on live so I can keep going. Hi, Bree. How are we doing? Wonderful. You're welcome. You are? That seems late. Hi, Kyla. Is that right? Yeah, it doesn't seem like. Do you have a first period? Yeah. Huh? Sure. Hi, Mitchell. What's that? Did you? What'd you win? What are those?
$50.
Nice. That's awesome. There you go. What's up, Derek? How you doing, man? Good.